Hello again, and welcome to 5-Minute Physics. Today's topic is Hooke's law and simple harmonic motion. There we go. So Hooke's law is really an equation. Hooke came up with this equation after looking at springs and such for theories as a theory for simple harmonic motion, which is what we call the moving back and forth, or oscillation, that objects do. So Hooke's law is as follows. F elastic equals negative kx, or spring force is equal to the spring constant times displacement. Now, for this, you really need to take a look at your setup. So for most situations, you would have either a pendulum on a string, which would look like this. Wrong layer, my bad. You have a pendulum on a string, moving back and forth. Or you have an object connected to a spring, a weight that'll move up and down, or oscillate. Alright, now there are three principles that go with Hooke's law for measuring simple harmonic motion, and those are amplitude, period, and frequency. Amplitude is measured in radians or meters, depending on whether you're talking about circles or not circles. Period is a measure of time, and it's measured in seconds, and frequency is a measure of cycles per second, and that's measured in hertz. So for definitions, we could say amplitude is the maximum displacement for equilibrium. So the farthest it moves, there we go. Alright, the farthest it moves, sorry about that. Yeah, that's better. The farthest your object on a string, say it's a pendulum, moves from the equilibrium point, which is this, would be your amplitude. So this distance here, or that angle rather, measured in radians. Period is the time that it takes to complete a full cycle. So if you have your object on a string and it goes to this side, and then it comes back and it goes all the way to this side, say it's got an extreme over there and over there, the time that it takes to get from here to here is your period, and that's measured in seconds. And frequency is the number of cycles or vibrations per unit of time. Again, cycles per second is equal to hertz. So if you have your object on a pendulum again, and let's say you've got 4 seconds, and it goes through a period in 1 second. So then you'd have over here, that's 1 second, then back over here, and back over here, 2 seconds, back to this side, and back to this side, 3 seconds, and so on. And so you end up with a frequency of 4 periods per second, or cycles per second, so 4 hertz. And there's an animation that I would like to show you. There we go. I'm going to have to make your screen a little bit bigger. Alright. This is a great animation because it just really shows an example of what this would look like. So here you have your animation, and I'll start a new one. Our spring constant is 18. Spring constant is the strength of the spring. I don't know if I mentioned that. And the mass of your object down here is 345 grams. And I'll have it show the force. And why not? We'll move in slow motion. Alright? So if we were to start this and drag it, say, that's that far. That's our displacement, plus x, however far it is, and minus x, the displacement to the other side. So that's the motion, and we're not accounting for friction here, so it's not really slowing down, it's just moving. So as you can see, the spring constant pulls it to this side, the force of the string, and the force in the other direction grows. Because, let's see if I can pause this. I don't think so. Maybe not. So as it moves to this side, as the object moves to this side, the spring is compressed, so there's more force in this direction. And as it moves to this side, the string is stretched out. So there's more force pulling it in this direction. So it will oscillate between those two extremes. So to show that again, let's drag it to this side this time. You can see that? Slow motion. You can see the force is moving with the spring. As the spring gets shorter or longer, the force grows larger or smaller. So to graph this, you can see the force increases as a position is moving farther. And there you have it. The force is weakest at 0 when the displacement is 0, because it's at rest. The object's not moving. At the extremes, the force is the highest, because there's the highest force pulling it in the opposite direction since it's at the extreme, like when the spring is fully extended or fully contracted. And that's pretty much it for Hooke's law. Thanks for watching, and we'll see you next time.